Well, good evening, everyone, and welcome to Dome at Home, Manitoba Museum's monthly astronomy show. I'm your host, Scott Young, and it is great to see you all here. We are at the last Thursday of the month, and that means it's time for our show. We're going to take a look at the things that are coming up in the next month or so, highlight some of the things to see in the sky, talk a little bit about some of the current and cool space stuff, and we're going to look ahead to the eclipse in April. It's already time to start making plans, especially if you plan to travel for it, because a lot of people will be traveling to see this eclipse. It seems like this is likely to be the most observed total solar eclipse in history, because it crosses right across Mexico, the United States, and Canada. And barring weather issues, there's going to be a lot of people driving. We thought 2017 was a big deal. That just lit the fire for this one, I think. So it'll be interesting to see. We'll get to that a little bit later. Hi, everybody. Thanks for checking in the chat. It's always great to see folks saying hello. And I started saying hi to people, and then I lost the bubble, and a whole bunch of people went by there. Hi, Ben. Hey, James. Stan. Nice to see you. Oh, Hollis from Connecticut. Nice to see you. It's like spring today, hey? We had cold weather last week. We're now sitting around -3, -2, and in the daytime it's going up. So basically they scraped the roads down to sort of a layer of ice, and now all of that ice has turned into slush, and the driving is just terrible. So you just can't win. Oh, hi, Kevin. Nice to see you. And Dale and James, nice to see you down in Emerson. What's the weather like down there? Is it, that's Manitoba's tropics down at the border there. So hopefully you have better weather. All right, let me put up my picture here so I've got a background. Okay, we have a whole bunch of things to cover today. And I wanted to make sure that we have a chance to answer any questions or things like that. So if you have any questions, please do drop them into the chat. I can see it out of the corner of my eye, and I will try and answer any questions about what we're talking about at the time. And if it's a question that's sort of about something else, I'll try and get back to it when there's sort of a gap. Those of you that watch the show regularly know that I don't stop talking very much, so it's hard to get a word in edgewise. But if you throw it in the chat, that's the way to do it. Oh, hi, Ulrika. Nice to see you. And oh, Kim as well. Excellent. It's lots of folks checking in. All right. Let's see. Where should we start today? Oh, I was at work the other day, and I got a chance to see my friends Fallon and Phil. They happened to be in the museum, and I managed to drop by and say hello a little bit. Fallon's been watching the show pretty constantly since it started, I think. I don't know if you've missed any. It's been quite a while, so it was great to see you guys. And hopefully, when it warms up a little bit, warms up and clears up a little bit, we'll be able to get out and do some telescoping together. That'll be kind of nice. The weather has been terrible. In case you don't live here in Manitoba, the weather has been just terrible for the skies. We've had a few clear patches here and there, but usually on those really, really cold nights where the wind chill takes it down to -40 or so. For our American viewers, that's still about -40. When you get to -40, it doesn't matter if it's Celsius or Fahrenheit. It's just really, really cold. So it has been terrible. I have not logged an observing session since November 28th. So some of that was the holidays. There were a few days in there that I probably could have gone out, but we had a family thing or something like that. But it's just been really, really bad. Oh, nice to see you guys, Len. Good stuff. Oh, I'm glad everything is working too. Oh, and Krishna from Houston. Linda, nice to see you. Krishna, we're always envious of your skies. I imagine that you have had some pretty decent weather in terms of clearness, at least. Although I guess there was some. I'm not sure. Oh, you're in Houston, yeah. Okay, so I'm not sure what the weather's been like there, but certainly it's going to be a little bit better than it is here. Oh, hi, Jody. Nice to see you. Okay. I lost my train of thought because I just wanted to say hi to all my friends. Okay, let us take a look at some of the things that are happening in the sky right now. We're going to start there. There's a whole bunch of cool space stuff to get into as well. And like I say, if you have any questions, drop them into the chat there. Kevin from Kingston checked in earlier, and he said he's in the middle of an eclipse planning meeting right now. So I think he's on two different teleconference or Zoom things at once. You'll have to tell us where you're heading to, Kevin, what the secret is, because there's still a lot of uncertainty for a lot of people about where should we really go to get the best view of this eclipse. Okay, but before we get to the eclipse, let us talk about some of the things happening right now. The sun has been really active. A few days ago, there were no less than 12 groups of these little dark spots, the sunspots on the sun. That's a lot of activity, and this is consistent with the idea that the solar cycle is going to peak late this year. So that means we get a lot of energy coming from the sun. That generally drives things like northern lights, and so the northern lights folks are very excited about that as well. And when you look at the sun in other wavelengths, you don't just see the sunspots, you also see all of these prominences and areas in the chromosphere. And these two dark spots that are near the center there, that's something of interest. Those are holes in the corona. They're called coronal holes. And those allow sort of bursts of radiation to come out of the sun over and above the normal levels. And that stuff comes on the way and hits the Earth, and that can trigger a northern light storm. There have been a lot of, you've probably seen a lot of those maps of Canada all covered with green around saying, oh, the northern lights are coming. Well, maybe. We still don't have the ability to forecast these things very accurately. And so all that it really means is you should be ready to go out and observe should the sky clear, because there's an increased chance of northern lights. Tomorrow is when this coronal mass ejection, this burst of material is supposed to reach us, but it might reach us during the daytime. It might reach us and not do anything. All sorts of different things can happen. So keep your eyes to the social media, and that's probably the best way to find out. As soon as you start seeing pictures of northern lights, that's the time to get in the car and drive out of the city. When they get very bright, you can glimpse them from the city, but it's really worth getting to a dark sky to see northern lights. Oh, Val's saying, I remember that sunspots always interfered with radio transmissions when I was young. Is that still the case? Yes. So basically, the sunspots, as the solar cycle increases, the sunspots are sort of a marker of the activity. And it interferes with radio transmissions because basically a lot of the material that's coming is electrons, which will interfere with all of the radio signals. Sometimes you'll get blackouts or fade outs or things like that. And even with satellites, you mentioned, even some poorly designed satellites can be affected by solar bursts. In the old days, they didn't really think about, well, what happens if the sun spews out all of this electricity and it goes into our solar panels? And basically you would get some satellites that would just die. Now, it was fairly infrequent because most people, when they're building something to go into space, realize that there's an environment there you have to take into account. But there were always a few problems. And then just, was it last year or the year before, my favorite company, Starlink, sent a bunch of satellites up into space, and they launched the day after one of these coronal mass ejections, not realizing that what it would do was it would hit our atmosphere, and it would actually make the atmosphere puff up a little bit because it's got more energy in it, it puffs up. And that increased the drag of their satellites, and rather than spiraling outwards to their orbits, they actually all spiraled in and burnt up in the Earth's atmosphere. So they lost an entire rocket launch of Starlink satellites because they didn't check the weather, the space weather. Keith's asking, can solar flares physically push a satellite a bit? There's not a whole lot of physical pressure that's involved. It's mostly electronic and magnetic kinds of forces that get involved. So it's more like it induces a current in the wires in your spacecraft, and suddenly you've got, 400,000 volts going through into your 12-volt battery or things like that. So it's really that kind of stuff. You do have that effect, though, if the atmosphere puffs up a little bit and the satellite is low, it can get increased drag, and that can change its orbit. So you do get orbital changes, but it's more because of the atmosphere changing and dragging on the satellite rather than physical stuff. Good question. Coming up in February, the moon and the planet Jupiter are going to have a very nice pairing. This is a view through binoculars, and they're not like right next to each other or on top of each other, but it's a pretty nice view. a nice thin crescent moon, and the planet Jupiter. So that's something to watch for. That's on February the 14th. So put that on your calendar, and hopefully it'll be clear. Interestingly, we've had a lot of months where there has been a lot of activity, a lot of things happening in the sky. We've been having things like, the moon goes past a whole bunch of planets, or we have meteor showers or things like that. February is a little bit of a slow month, actually. There's not a whole lot of those things going on. And that's mostly, I think, because the only planet that's really prominent is Jupiter. We've still got Jupiter in the evening sky. And as we click over to our stellarium view here, the evening sky, well, technically, I guess there's Saturn setting just as it starts to get dark. Saturn's pretty much gone for the year. But Jupiter is nice and high up in the southwest, and that's really the beacon that's up in the sky. But there aren't really any other planets that are bright, that are visible, unless you want to get up just before sunrise. Venus pops up above the horizon just before sunrise in a bright twilight sky. So we don't have as many of those sort of events of the moon going past things or things like that. But we do have a wonderful set of constellations to look at. Orion the Hunter, the centerpiece of the winter sky, nice and bright. The three stars in his belt, very, very easy to spot. This is Betelgeuse here, or Betelgeuse if you prefer. That's how you're supposed to say it. That's a red supergiant star. I think we talked a little bit about Betelgeuse last month when we were talking about the life cycle of stars. This is Rigel down here. And you can use Orion basically the same way we use the Big Dipper to sort of connect the dots and point to other constellations. The belt of Orion points down towards the bright star Sirius in Canis Major. This is the big dog. The belt points up towards Taurus the bull with the V-shaped Hyades star cluster up at the top there. And just off the top of the screen, I'll pull it down here, the Pleiades star cluster. And Jupiter is pretty close to the Pleiades, so that's sort of connecting the sky there. If you go from Rigel, you go up through the belt and through Betelgeuse, you sort of wind up in Gemini over here, where we've got the two twin stars, Pollux and Castor. And then if you go from the top of Orion's shoulders and you draw a line out, and this one isn't very straight, but it's close enough. You come to Canis Minor, the small dog here with the bright star Procyon. So you can basically find all of these things just by using Orion the Hunter. One of the things that I like about Orion, he really does look like a person when you see the stars in the sky there. And if we zoom in here, hanging from his belt is a sword. And in the tip of the sword, again, I think we talked about this a little bit in the last show. Oh, where's our picture here? Let's get our picture. There we go. The Orion Nebula, a big cloud of gas. This is a beautiful thing to look at in any instrument, whether you got your eye, binoculars, a telescope, a nice low-power wide-field telescope makes a glorious view of the Orion Nebula. You can look at it for, half an hour and still not see it all. It's a wonderful, wonderful object to look at, and only visible in the winter. And lots of the winter sky is nicely on display right now. So if the sky was ever to clear, we could conceivably take telescopes outside and look at things. That's what I'd like to do. But unfortunately, that hasn't quite happened recently. Let's see in the chat here. Oh, Ben's pointing out that Starlink is now doing direct to cell phone texting. So they've really come a long way in their technology and stuff like that, which is pretty impressive, really. Melissa, I was reading that the Earth isn't the only planet in our solar system to create beautifully colored northern lights. Yes, that is accurate. Any planet that has a magnetic field around it, like the Earth does, and an atmosphere, will have some kind of northern lights. And of course, southern lights, the mirror image on the south side. You basically wind up having the particles from the sun getting funneled by the magnetic field up towards the North Pole and the South Pole, and they collect in whatever atmosphere there is. The problem is, really, Earth is perfectly positioned for this because we're close enough to the sun that we get a good blast of energy, but not so much that the sun has stripped our atmosphere away like Mercury and just completely removed all of it. So we're kind of, I think we have the best northern lights. Maybe I'm biased, but for sure, I would say Earth is right up there. Jupiter and Saturn both have aurora that have been seen in their atmosphere. And actually, surprisingly, Mars, if I recall correctly, even though Mars's magnetic field is very, very weak, it does have very, very minor aurora. I remember reading that a couple of years back. I can't remember the source though, and so I'm going to have to, don't quote me on that 100%, but I'm pretty sure that was the case. We expect that Uranus and Neptune also have aurora, but they are so faint because the sun's energy by the time it gets out there is very low. It doesn't make very bright aurora, and the planet is so far away that very bright aurora is even harder to see. So we don't really have a lot of images of that, but it is likely that both of those also have them. We'll have to see about Pluto too, because in 2015, the New Horizons spacecraft went zooming past Pluto, took all these pictures and showed that it has this multi-layered atmosphere and that there's all sorts of interesting things going on there. There may be something going on even as far out as Pluto. That would be really cool. Oh, hi, Tracy. Nice to see you as well. You're never tardy. It's all good. And James, yeah, imagine that, clear skies. I know. We just have not had great skies. But anyway, that's the advantage of Dome at Home and the planetarium and things like that. If you need your fix, come down to the planetarium, check out one of the shows. We've got The Edge of Darkness, which is all about Pluto and the outer edge of the solar system. We've got a special kids show called In My Backyard that has Fred Penner in it that's been popular for decades. And we have our regular Manitoba Skies show, which is, of course, all about what you can see in the sky. So there, it's always nice and warm, and it's always clear, unless the planetarium operator wants to be mean and turn on the cloud button. Okay, we are going to go back to Jupiter here, because one of the things that is interesting at this time of the year is that you all know that Jupiter has moons, and we've talked about Jupiter's moons before. We've looked at them from spacecraft. We've looked at them, in telescopes. They show up. The 4 brightest ones can even be seen in binoculars. And they're really these interesting little worlds. Well, where Jupiter is in its orbit right now, it's already way over in the west at sunset. It's sort of not quite at a right angle from us, but it's getting on to the area of its orbit where the sun angle to Jupiter is very different from the sun angle that we have. And what that means is that as the moons go around, they can have some really interesting hijinks as they go around the planet. The orbit of the moons is basically in the plane of our line of sight here. So these moons will just sort of move around this way over the course of a few days. But they can duck behind the planets, they can pass in front of the planets, they can cast their own shadow on the planet, and the shadow of Jupiter, which extends out this way, can also eclipse them. So as these moons go around, they don't just sort of move, they have all of these interesting phenomena. So we're just going to jump ahead to one of the days here. Let me just see here. There we go. And so here we have, actually we'll just back up a little bit. There we go. Here we have January 29th. And now that I've said that, I've guaranteed that it's going to be cloudy that night. I apologize. But January 29th, around 6 o'clock, here's the view of Jupiter if you were to look at it in binoculars. You would probably see Jupiter in the center. You'd see Callisto off on the left here. You'd see Ganymede off on the right here. Those are far enough away that even binoculars will split them. Europa is right next to Jupiter, though, and so you'd probably need a telescope to see that. But as time goes on, we're actually just going to do a little fast forward here. I realize, there we go. We'll just turn on the speed a little bit. It actually, Europa moves in behind, which is great. And the planet slowly rotates. You can see the clouds slowly moving and so on. Now, you would expect that since Europa has moved behind Jupiter, it will reappear after some period of time, right? Well, if you wait a couple of hours, a satellite does, in fact, reappear. But it's not Europa. Io was behind the planet the whole time, and it didn't reappear when it came out here because even though it's come out behind the planet, it's still in the shadow being cast by Jupiter. The sun is way off to the bottom right here. So there was a shadow that went all the way out to here, and so Io suddenly materialized out of nowhere, like it sort of beamed in and appears there. Well, let's just let time go a little bit more here. Europa's got to come out eventually, right? So Europa does in fact reappear, and it reappears basically right on the edge. Let's see, where is it? There it is. It appears right on the edge of Jupiter. Io didn't. Io reappeared way out here. Europa appears right on the edge here. That's kind of weird. Well, it gets weirder. If you wait another 15 minutes or so, Europa will move away from Jupiter's disk and then disappear again. The shadow cone of Jupiter is basically a cone that points off away from the sun. Europa's orbit and Jupiter's orbit are both inclined to our line of sight so that Europa is sort of skimming around the North Pole here. And so it comes out from behind Jupiter. It's visible for a few minutes, and then its orbit carries it into the shadow of Jupiter, and it disappears again. This is all over the course of about 2 hours. So if you have a telescope on the 29th, that's one particularly fun night to go out and watch the hijinks of Jupiter's largest satellites. And they're always doing something. I mean, every single night of the year, they are, visible. So if we jump ahead by days here we've got on the 30th, there's Io's shadow stuck there. And on I guess we'll go to a darker sky here. Getting into February, look, we've got the great red spot that becomes visible here. And if we get into earlier in February, let's see, what was the date? I think, there we go. There's a view on the 5th where, one of the moons looks like it's underneath Jupiter, and these other two are off at a very, very close angle. On that particular night, if you watch the motions of things, you wind up, again, seeing one disappear. And then you get a view of Jupiter like this, where you've got one moon underneath it and one moon off to the side. It's going to look really weird, especially if you've been watching Jupiter for a while. This is a really cool time to do this. I'm planning, again, if the sky ever clears, to do some time-lapse imaging with the telescope camera, and we'll try and stream that live if the seeing is good enough. But otherwise, I'm going to try and make some of these neat time-lapse movies showing the motions of these things, something that even 10 years ago we couldn't dream about doing as amateur astronomers. Now you just buy a $200 camera and you stick it in your telescope instead of an eyepiece, and then you learn to use some free software. It's pretty cool what we can do nowadays. Okay, let's zoom out a little bit here. So Jupiter's satellites and their shadows have all sorts of fun things to watch. You do need a telescope to see that level of detail, but it's well worth checking out if you get the chance. Sometimes you'll look at Jupiter and you'll just notice, hey, there's only 2 moons. Look to see where they are. Sometimes you can see one of them passing in front of the planet. There's actually a little bright spot on the planet itself. Sometimes you'll see the shadow. Sometimes it'll be in behind and you won't be able to see it. All this information is available in various astronomy books or online. Stellarium, the program that we normally use to show everything here, will show you all that detail, so you can basically plan out exactly what you would like to see in, what things are going to look like for your observing night. Jenna, thanks for that. You liked In My Backyard. I'm really glad. Yeah, it's a great show, particularly for really young kids. It doesn't make a big deal about putting them in the dark, and there's some fun songs to sing along, and they see the planets and stuff. It's a really fun show. Let's see. Melissa asks, is that related to the Jovian day rotation or the oblong orbital pattern, or both? Let's see. Oh, the angles. There's a couple of things that is going on. Jupiter rotates about every 10 hours, but it's not solid. So the middle part of it rotates at 9 hours and 50 minutes to go around, and the outer layers are 9 hours and 55 minutes. So the clouds of Jupiter are always sort of going past each other, and the surface features basically get out of sync. This middle part moves a little bit faster than the other parts, and so there's always new things going on there. The moons are all basically within a couple of degrees of the equator of Jupiter, but Jupiter is tilted about 3 degrees with respect to us right now. Not enough to really notice it. You can't see, like when you look at these cloud belts. Oops, here we go. Hey, where'd you go? You can't see things like, you know, the cloud belts are not curved or anything because we're not looking down on it enough. It's only a few degrees, but that is enough for the moons, because they're quite far off in the background or far in the foreground, to really get this shifting, and it looks like they're above and below, but really it's just because their orbits have been shifted a little bit, and because they're moving way out in front of the planet, it really looks like it's gone down below, when actually it's just because the plane is shifted a little bit. Anyway, it makes for lots of fun things. Ulrika is asking, will you do live streaming and setting up a public telescope again? Yes, we will, if the sky's ever clear. Actually, you know, February is traditionally not a great month clear sky-wise, but then again, January is usually a very good month clear skies-wise, and it's been terrible. So I think all of our predictions of what the weather is supposed to be like are pretty much off. It really will depend on when we can do that. I can do a live stream from my backyard fairly easily. To set up a public night where we can go and do things as a group, we're going to definitely do that as well. But that's probably going to wait till it's a little bit warmer and a little bit more more predictable weather. So Alex says it's going to be clear this Friday. Really? Oh, that's fantastic. Wait, what is this Friday? Like tomorrow? Is there something? Oh, of course it'll be clear tomorrow. I'm busy tomorrow, but that's okay. Maybe I'll change my plans. It would be worth it to get out and get some clear skies. Okay, let me see. So Jupiter really is the highlight of the month. We've got the spring constellations are starting to rise up in the east. If you go outside, in the early evening, say 8, 9 o'clock. We've already got Leo the lion showing up here, a little faint Cancer the crab, and then right next to that is Gemini. So the winter and the spring sort of abut each other pretty quickly. But as the night goes on, you actually wind up getting all those spring constellations starting to rise up. So Leo, Virgo down here, this is Coma Berenices, and this whole region in here is the realm of the galaxies. This is the Virgo galaxy cluster. In a telescope, there are dozens and dozens of galaxies in there. There's a galaxy in this region right now that just had a bright supernova in it a little while ago. It's got the wonderful poetic name NGC 4216, and it has a star that exploded in it, like Betelgeuse will do one day. And it is that one star is now basically as bright as the whole rest of the galaxy. So pretty powerful kind of thing. And we can see it, 30 or 40 million light years away as this little star that is cooked off in this galaxy. I'm hoping, if we get some clear skies, to get some images of that. But unfortunately, it's been really hard to do that. But we'll have to see how, if it's going to be clear Friday, we'll have to see what Saturday morning is like early. Because I think right about now that area rises around, probably, 2 or 3 in the morning is when it's up high enough to get past my garage. Oh, I don't know if I told you, but if any of you were at the Winnipeg Center Astronomy Club meeting, the RASC last week, 2 weeks ago, one of my neighbors cut one of their trees down. One of the ones in my southern horizon. I've got a whole bunch of trees that I always have to move back and forth. In fact, I think I've shown you what my horizon looks like from my backyard, and it's like this. So I can't see Orion except for about half an hour in the morning and half an hour in the evening because all these trees are in the way. This tree right here is now gone. Oh, it's so wonderful. So we'll have to see if maybe some more of those trees we'll have to get down. Okay, yeah, chainsaw aided astronomy. Yeah, I saw driving down the lane, I saw that this tree, which it was in pretty rough shape to be fair, just had a big red spray paint dot on it. And then 2 weeks later, they came out and they cut it down and chopped it all up and made it into mulch. So I bet I have some red spray paint somewhere. No, of course we won't do that. But it really is, has opened up a whole, like I can now move my telescope to a different part of the yard and see a whole different part of the sky that I couldn't see before. So for those of you that have nice flat rural views, you don't know how it feels when a tree like that has to be moved out of the way. I mean, I could cut down trees in my yard, but I don't want to just cut down a tree for no reason. Like this one was diseased or something, so they had to take it down. So I'm not a tree killer. Okay, let's move on because there is a whole bunch of stuff to talk about in the category of
cool space stuff.
Yes, cool space stuff. I can't believe the amount of stuff that happened in the last month. We were talking a little bit about how the Artemis moon missions have been delayed. There was NASA did a special release and said, well, we're going to push the moon missions close to a year because they were very nice. They didn't point any fingers and they sort of said, well, there's this that has to be done and this that has to be done. But Artemis 2, the spacecraft that Canadian astronaut Jeremy Hansen is on, doesn't have as many problems with it as the next mission, Artemis 3, because that one's supposed to land on the moon, and it's supposed to land using a SpaceX Starship-based lunar lander. And as you may know, Starship has yet to fly anywhere without exploding. And there's a huge amount of work to be done before they're able to put people on it and take it up to Earth orbit and then fire it to the moon. They have to fuel it using 10 separate missions while in Earth orbit before they can send it to the moon. I didn't realize how daunting of a prospect it was. And of course, it's because NASA said, we want a little moon buggy like the lunar module that we can basically go down to the moon and come back with. And SpaceX said, okay, I'll give you a 15-story tall, gigantic rocket that can do a whole bunch more than that, and we'll make it land on the moon. So it's definitely a mismatch in, you want to under promise and over deliver. And I think right now we're in the opposite kind of situation. We'll have to see. I mean, they're gearing up for the third flight of Starship in the next few months, probably. They've got 20 months until they're supposed to land on the moon with a Starship. So we'll have to see exactly what's going to work. We'll see. But anyway, that sort of started off the lunar segment of all of this. Yeah, Kevin, wait and see if the LEMs in museums suddenly disappear. It's funny, to go from lunar orbit to the surface of the moon is relatively simple. The hard part is to do it with people on board, have those people get out, walk around, pick up some rocks, get back in, come back up to orbit, and then make it back to Earth. So it's not a challenge that is minor, but I think they've added so many extra features that nobody asked for that they're going to have a hard time delivering. Anyway, I don't want to derail too much because I could rant about Starship for a little while. But here is the Japanese lunar lander, SLIM, and it landed on the moon softly, safely, just a few days ago, not without problems. Unfortunately, and we just saw sort of today that one of its two engines as it was going down had some problems, and so the other engine compensated, but that sort of threw the balance off. And so when it landed, it was designed to land on a slope. You can see there's a slope there, so that the solar panels would be tilted towards the sun. Well, because of the imbalance, it basically rolled around, and now the solar panels are facing into the shadow. And on the moon, the sun doesn't move across the sky every day like it does here on Earth. The moon takes 28 days or so to go all the way around. So they used the battery to get a few pictures back. This is taken from the one of the two rovers, pardon me. They had one little sort of tennis ball sized hopping rover and then a second one. And one of them can send pictures back directly, and one of them sends it back through here. So this is the main spacecraft lander, that golden thing with, and yeah, Kevin, pointy rocket engine and goes down. Yes, that's exactly the problem. So it's pretty much upside down. But they got these pictures back. They turned the batteries off. And in 2 weeks, when the moon has moved in its orbit and rotated so that the sun is now shining on the western side, they're going to hope that the solar panels will charge the batteries then, and they're going to turn it back on. So they landed successfully, and they landed within 3 meters of their target spot. Apollo 11 landed, I think, 6 miles from its target spot. The best Apollo landing was something like 300 yards from their target. This was 3 meters. So this is pinpoint landing. You could land in your driveway pretty much. So that's really impressive for an automated lander. And hopefully the problem will only just mean a 2-week delay until those solar panels can charge up, and then they can do the rest of their mission, take all sorts of pictures and send stuff back from the rovers, and I'll do all the science and things like that. So that's pretty cool. Japan becomes the 5th country to ever soft land anything on the moon, and they're pretty excited about it. Right now, there are 4 European astronauts on a private mission up to the International Space Station. It's the Axiom mission. They flew up in a Falcon spacecraft, and they're up on the space station for a couple of weeks, and then they come back down. And there's some science involved, and there's some publicity involved, and things like that. It's a little bit of tourism, but oh, hey, Phil and Fallon, nice to see you. I gave you a shout out about running into you at the museum the other day, so you missed it. You'll have to go back and watch it on the saved version. So these 4 astronauts are currently up on the space station. It's the first all-European mission to the space station. Usually the Europeans go up one at a time on either a NASA or in the old days a Russian spacecraft. But now this is the first time that's a crew of 4 Europeans. So that's another cool kind of milestone. This is one that maybe will impact us. The Boeing Starliner. This is Boeing's version of the Dragon spacecraft, essentially. It's designed to take astronauts to the space station and to Earth orbit to do all sorts of other things. They got funding from NASA just like SpaceX did, and SpaceX was sort of the first group, and they've been flying regularly now. Boeing started a few years later, but then they ran into some development problems, and it was not. They've had their missions bumped a number of times. They're going to be flying in April, it looks like, with 2 astronauts to the International Space Station, just on a sort of a touch and go test. They're going to fly up there, they're going to dock, they're then going to undock, and they're going to come home. And it's literally to sort of prove that the spacecraft is finally ready to carry astronauts and is safe enough to operate in the International Space Station's airspace, for lack of a better term. You really don't want a spacecraft coming near your expensive space station if you don't know that it's going to work properly. And so they've been doing a bunch of tests without crew, and this will be the first crewed flight. If that works, that means that Canadian astronaut Josh Kutrick will go on the first operational flight to the International Space Station later on this year, which would be great. Having said that, I mean, it doesn't take a news junkie to know that Boeing has been in the news recently for a bunch of not great reasons. And it seems that their Starliner spacecraft, they haven't had hatches falling out or anything like that, but they certainly have had their share of sort of technical problems that have delayed development of this. This was supposed to be flying 3 years ago, and so I'm not sure it's maybe glib to connect it to the problems that Boeing planes have had. I mean, they're totally different divisions of companies and so on. But it does seem that they've had sort of this unlucky period of development. So I really hope that the Boeing Starliner will fly in April or soon thereafter and will work perfectly. Then there will be more than one spacecraft that can get astronauts up to the space station and back. Of course, there's still the Russian Soyuz, but we don't hang out with them nearly as much in space anymore. And so that will be really cool because it'll be great to see Josh Kutrick up there on his 6-month trip to the International Space Station. Lots of cool Canadian stuff in space this year and next. Let's see here. Oh, this is cool. So Jupiter, we've got this spacecraft out there called Juno. It's been in orbit for a few years now, and it sort of loops around close to Jupiter, and then it sort of zooms out far because Jupiter is surrounded by a radiation belt. Its magnetic field is so strong that it collects all that stuff from the sun and it just keeps it there. And some of it reaches the atmosphere to make aurora, as we were talking about, but a lot of it is just sort of trapped in this radiation zone around Jupiter. If you have your spacecraft living in that radiation zone all the time, it's just going to fry your computers eventually. So Juno dips down low to get good pictures, flies through the radiation zone, and then pops back out and spends most of its time quite far away from Jupiter. Well, as it does all of these loops, occasionally it will come close to a moon. And so Juno is going to be flying past the volcanic moon Io. It did one flyby last month, and it will be flying by again on, I think it's February the 3rd, down to about 1,000 kilometers altitude, which is pretty impressive. And so if you're keeping track, Io has the most active volcanoes of any place in the solar system. Even though Earth is, 4 times bigger, Io still has more volcanoes. It is close enough to Jupiter that the gravity of Jupiter just pulls on the inside of Io and melts the inside, and you just have these massive pools of magma that come rocketing out of these volcanoes. And it's a really, really new surface because it's literally repaving itself constantly from all of these volcanic action. So we're going to get some great pictures of that. Hopefully see some actual eruptions going on as well. And so that's coming up on the 3rd. And what else there was another one here, I think. Oh yeah, speaking of flybys, the Parker Solar Probe. This is a spacecraft that was launched a couple of years ago, and its job is to reach out and touch the sun. It's got a big heat shield and a few instruments behind that heat shield, and it's going to get to the sun. The problem is getting to the sun is really hard. Well, no. Getting to the sun and surviving is really hard because out here at the Earth, as we go around the sun, we've got a certain amount of speed. And when you launch from the Earth, you've got that speed. You actually have to slow down to fall inwards to get towards, the other planets, the inner planets or the sun. So it's actually flying past Venus, and it's doing a reverse slingshot. Instead of slingshotting around a planet to pick up speed, it's going in a different kind of path to slow itself down enough. And it's been doing a bunch of these flybys. I think this is number 8. It would be really cool if the Parker Solar Probe had been designed with some cameras that could look at Venus while it's going by. It really wasn't. It was designed just for the solar activity, and having an extra set of cameras would have just made it very, very complicated. Ryan's saying it's a Molina orbit. Yes, that's exactly right. The Molina Russian spacecraft, Russian satellite, communication satellites things sort of go in very close and then they loop way out, and then they go in very close and loop way out. That's the same thing that Juno does. And actually that is what the Parker Solar Probe is also doing, as it sort of loops around Venus, and that slows it down, and eventually it can head in towards the sun, and it will pass very, very close to the sun, touching the sun, flying through the solar corona, where the temperature is around 15 million degrees or so. Very ambitious mission, and if it all works out, I'm sure we will have some groundbreaking discoveries from it. But I really wish they could be checking out Venus while they're going past it anyway, because Venus is such a place that we haven't really explored very well. There have been lots of attempts. There's lots of dead robot spacecraft on Venus that have been melted by the temperature or crushed by the pressure or dissolved by the acid in the clouds or whatever. But in the last few years, we think that actually high up in the clouds, it's plus 480 degrees Celsius at the surface. It's minus 200 degrees or so Celsius in space. Somewhere in between there, it's, 18 and sunny. So that's about 50 kilometers up in the atmosphere. What we really want is a balloon mission that could basically go into the clouds of Venus and sample that atmosphere and see what's in there, because there are chemical indications that there could be some form of life in the clouds of Venus. I used to say, of all the places we're going to find life, I am 100% sure we'll never find it on Venus. And I'm apparently wrong. So no, we haven't found it for sure, but there are chemical signs that maybe there could be something there. I want to find out. I want to know. And they've got this spacecraft that's literally driving past Venus repeatedly. It just seems like such a missed opportunity. But of course, you can't just add extra things onto a spacecraft, I'm sure. There's budget and weight and all that kind of stuff. But, Ben's saying there's a mission to Venus in the next decade. There's a couple of proposed ones. One is the balloon one, and then there was an orbiter with a lander probe, I guess, not like a rover or anything, but just a thing that would go through the atmosphere. I don't think either of them have been okayed yet. They were all. The way they do this is there's a big sort of competition, and all the scientists sort of take their personal pet projects or the things that they think should be done, and they develop these plans, and then it goes into a big committee. It's kind of like the Academy Awards, really. And so NASA picked the big mission. The next big mission will be an orbiter of the planet Uranus, which is also super cool. We've only seen Uranus up close once for about 4 hours as Voyager 2 went zooming past it at 30,000 kilometers an hour. Never orbited it, really haven't seen anything going on out there. So that's cool too, but I mean, life, come on. Anyway, we'll have to see exactly what is the next set of missions and exactly what happens here. Let's see. Trying to get this going. There we go. Okay. There's a whole bunch of other cool space stuff that is coming up that I'd like to get into, but we'll have to leave some of it for now. I'll do a few things up on the Scott the Skywatcher page as we go along, and I do hope to do a live telescope thing, at least a live stream, as soon as we get some clear skies. But now I want to jump back to what Kevin was talking about, the eclipse planning. It's time to decide if you're going to stay here to observe the eclipse or if you're going to go somewhere else. Now, in a lot of eclipse tours or things like that, all the tours are sold out. If you call all the towns that are in the path of totality, their hotels are all sold out. They've been sold out for a long time. But it's not like an eclipse where it's going through the middle of the Sahara or something like that, and there's only a few towns that you can deal with. You don't need to stay there in the eclipse path. You can stay anywhere and drive a couple of hours on the morning of the eclipse. The eclipse happens in the afternoon for us here anyway. And so this is the kind of eclipse that you can definitely have some ability to move around, which is good because the weather forecasts are not great. For those of you that are going to stay here in Winnipeg, you'll see about a 50% eclipse, and I'm hoping that we will be able to see a decent view. I'm going to be running a public event. We're hoping to be back at Assiniboine Park, although we haven't confirmed that. That's where we were for the October eclipse. It was wonderful there. But that information will come out in the next little while. We have eclipse glasses already at the museum's shop. The museum shop is only open on the weekends. However, you can go on to the museum shop's website, buy things online, and then come and pick them up at the museum any day of the week. So you can effectively get them anytime. They're $3 a pair, and there's a price break if you want to buy a set for your class or something like that, like a big amount. I recommend, if you don't already have your eclipse glasses, get them now, because they will not be around by eclipse time. Last eclipses, we usually sell out the day before, and it's going to be, there's no way to get any more. There's kind of a worldwide shortage of eclipse filter material because everybody is selling these things. There was a question, welcome to Waka, where I'm staying. Krishna. Yeah, okay, that'd be awesome. Actually, a friend of mine who moved down to Mexico is about 45 minutes south of the eclipse of the central path. So if I wanted to fly down to Mexico, I might have a spot there. But Texas is the place to go if you want to have good, reasonable chances of weather. It's April. April showers bring, well, whatever it brings, it doesn't bring eclipse views. It's going to be cloudy in a lot of places, and it's going to get worse as you get farther north and east. I don't know if you've ever been to the Maritimes. It is a wonderful place. I love it. I would go there again in a heartbeat, but the spring is not a time I would expect to see clear skies in a lot of places. Most of the places are way less than 50% chance of clear skies. Right at PEI and the coast of New Brunswick, it's almost 50%. But most of the rest of, just south of Toronto and through New York and stuff like that is like 20, 30% chance of clear skies. If I'm going to travel that far, I want a better chance to see it. So most people really have that option to, if you have that option to travel, you want to go south rather than east. However, if you're already making a trip, or if you've got, connections somewhere, or if you've always wanted to go to Montreal or, Halifax or whatever, I don't want to dissuade you from going. If you were only going for the eclipse, I would look at the weather. But there's so many wonderful things for the, in Eastern Canada. I took the train out there one year and basically just drove around, Nova Scotia and New Brunswick and PEI and stuff like that for a few weeks. It was just wonderful. Lots of great spots in New York. And then, like I say, there's, Texas and Mexico and so on. Karen, you're going to Dallas. Yeah, Dallas will be a popular spot, probably the biggest city in the path, like directly in the path. And I know that they're going to have lots and lots and lots of people and lots of programs and lots of, activity. I think that's where Bill Nye is going. Bill Nye, the science guy, is going to be in Winnipeg March the 3rd. And he's running a contest right now where you can basically win a chance to go and see the eclipse with him. And I think he's going to be around Dallas. Anyway, so if you are going to stay in Winnipeg, you're going to see a partial eclipse, and we can have a nice fun event like we did in October here. If you're going to drive, you really got to make your plans, or drive or fly or travel, however you want to travel. You really got to make your plans. And you don't want to try and do this the last minute. They won't, you might find out that 3 hours before eclipse time, and you want to just drive down the road 100 miles or so, and the road is packed because everybody is trying to drive down that same road at the same time. You just make sure you give yourself some time. The only thing worse than going to an eclipse and being clouded out is going to an eclipse and being late for it under a perfectly clear sky. It would have been clear, but you didn't get there in time. So there's a bunch of great stuff online. The Eclipsophile website is probably your best bet in terms of evaluating the whole eclipse and stuff like that. I'll drop that in the chat here. That's done by Jay Anderson, who's here in Winnipeg and is sort of the world, he's the eclipse weather guy, basically. And so that is probably a great reference. And if you are going to go, let me know. I would love to see your pictures afterwards. I'd love to maybe be able to even chat with you while you're down there the day before or something like that. if you happen to be going and you want a live stream, I will set you up with a camera and a telescope and the whole deal, and you can, do a live stream and send it back to me so that I can live vicariously through you. Anyway, really a great event, so you want to check that out if you can. Let's see. We have we had a question here that I wanted to get back to. Jacqueline's asked, any news from the asteroid sample? Yeah, the OSIRIS-REx spacecraft. It's OSIRIS-REx sampled from the asteroid Bennu and came back, and it dropped its sample off, and that came plummeting down to the Earth, parachuted down, and then they couldn't get the lid off. And so it's been weeks of, there is a little bit of dust on the outside that they were able to get, but the main sealed container, they couldn't get it open. Well, they got it open. And there's piles and piles of material in there. Some of that material has already made its way to Winnipeg, the University of Winnipeg. Dr. Ed Clutis is one of the guys working on that mission, and he was able to take a look at some of this stuff. I think he got some from that first batch, so I don't think he got to sort of keep it yet. But I know that he's on the list to get some percentage of that material from that asteroid to do the science on, which is really, really cool. So I'd like to get him on the show at some point and have a little chat with him, because he's a fascinating guy. So that was a cool thing that occurred. And let's see. Bob. Hey, Bob, nice to see you. Bob and I went to school together. Oh, yes. Bob and I, in fact, didn't see the eclipse in 1979 together. Yeah, that was 1979, February 26th, 11:16 in the morning. Some people... I don't think we got sent home. I know that the kids that went to school sat in the gym and watched it on TV. My mom kept me home. So maybe if you were at home, your mom and dad must have just kept you home, because they had that option. And I'm glad we did, because I stayed in my mom's bedroom with the blinds drawn and watched it on a smaller black and white TV. But then during the total phase, during those 2 minutes and 14 seconds when the sun is completely behind the moon and it's safe to look at, I opened up the blinds and the shutters, and I looked up and I saw this magical hole in the sky surrounded by blue fire. And that's the corona, the part of the sun that normally we cannot see because the bright part just overwhelms it. The moon blocked out the bright part. We got this beautiful view of the corona. And right then I became an astronomer. I didn't know what that meant. I didn't know what the path would be, but I was like, I have to know more about this. I have to do this. This is the coolest thing ever. So I can verify that eclipses can absolutely change your life. And so if you do have the opportunity, this is the last easily accessible North American eclipse for a number of years. There's one off in Australia in a couple of years. There's one across Africa. There's one that goes across Spain in the next few years. But in terms of North America, it's not very good. And then the next eclipse that comes through Manitoba again is, I believe it's 2157. I'm not going to make that one, I don't think. So I may have to travel to see another one. All right, I think that brings us to the end of our programming, and it's just about 8 o'clock. So hopefully we'll get some clear skies. We always love to see what you're doing in astronomy. If you want to send us pictures, you want to send us a description, a story, a drawing, anything like that, hit us on social media, or you can email us at space@manitobamuseum.ca. I love to be able to show people's images and you know what you're doing. We can make it part of the show. It really inspires other people to get out there and do stuff as well. So definitely send us your pictures and things like that. And we will be doing the next show, which will be the last Thursday in February, which is the 29th. That's right. It's the leap year, February 29th. And so we're going to talk a little bit about all the dumb things we do to our calendar, like leap years and daylight savings time and all that kind of stuff. So there will also be a lot of really good stuff in the sky, because as we get into spring, we get into all sorts of, we all come out of our shells and we all start to do some observing. Thank you everybody for joining us. And I really hope to see you all soon under the sky. We'll get a public session going when we can. And at the very least, April the 8th, we'll be doing one for the eclipse. So thanks again. Have a great evening. And I wish you some clear skies. Good night.